This is the first video in the Classical Liberal Arts Academy's Classical Geometry course. And in this video, what I'd like to do is introduce you to the study of classical geometry to help you make a good start to your studies in this important course. The first thing I'd like to recommend is that you take some time and go and watch the first video that I made to introduce classical arithmetic. In that video, I introduced not only arithmetic, but all four of the classical mathematical arts. And in that video, you'll get a good understanding of where geometry fits into the four classical mathematical arts. So take some time, either after you watch this video or now, and then come back to this video, but watch that first video on the introduction to classical arithmetic. You'll find that helpful. The Quadrivium is the collection of four mathematical arts that are part of the classical liberal arts curriculum that was studied throughout world history. The Quadrivium is made up of four arts: arithmetic, music, geometry, and astronomy. Geometry, the art that we study in this course, can be considered the second of the four mathematical arts because it's easy to begin once you've made some progress in classical arithmetic. So obviously, if you're taking this course, I recommend that you take classical arithmetic as well, and you try to make a little bit of progress in classical arithmetic as you get started with geometry, and go through the two of them together, but give classical arithmetic a little bit of a head start so that the ideas that are studied there can be used as you work through classical geometry. What's confusing in modern times is that when we talk about geometry in modern schools, we're usually talking about shapes and sizes, and we think about things that we can see and touch and measure, things that are physical and visible material bodies. And that's not what we're actually concerned with in classical mathematics or in classical geometry. We're not studying physical objects. So if I talk about a circle or a square or a cube or a cone, we're not talking about a figure that you can hold in your hands and look at. We're talking about perfect imaginary forms, forms that may not even exist in the visible world, forms that we are imagining based on definitions that we give and in proofs that we make using axioms and postulates and definitions. And so I want to make it clear that this is a philosophical study. We're not studying the sizes and shapes of physical bodies. We're studying magnitudes that are at rest. And when we talk about magnitudes, again, we're not talking about physical bodies. We're talking about ideas of things in their perfect forms based on definitions that we're going to learn and establish in this course. And if you simply look at the definitions, you'll see that these things don't necessarily exist. They're simply ideas that exist as definitions, and that's what we're to understand. The reason why we're studying magnitudes at rest in this way is because this is a part of the study of classical reasoning. And again, I explained this in the introductory video to classical arithmetic, so I don't want to explain it all again. But to put it simply, when we talk about objects or think about objects, we think about ideas in our mind and we say things about them. One of the things that we can say about a subject is that it has a certain quantity. We can say that this marker, what is this? We can describe the substance and say it is a marker. That's substance. That's one of the 10 categories. But we can also say how many is this? And the answer would be, this is one. So we could speak of a subject or think of a subject with reference to a quantity. Okay, so a quantity is something that we can say or think about a subject. And in geometry, we study one kind of quantity that can be spoken or thought of some subject. We're not talking about measuring the sizes and shapes of physical things. Okay? I want to make sure that that's clear. All of this is about ideas in our minds, and these ideas may not exist in the visible physical world, but they do exist in terms of definitions and ideas in our imagination. And that's an important difference. So in geometry, we're studying the idea of magnitudes at rest as a part of philosophy, the pursuit of wisdom, because these ideas must be present in the mind of God, because we can see that in the created world, he used these ideas and images to create things. We find these figures. For example, the earth itself is formed in the shape of a sphere, which we're going to study in geometry. We're going to learn that there are certain characteristics of that figure that make it fitting that God would design the earth in the figure of a sphere. He didn't design the sun to be a giant cube that moves through the sky, or a triangle or a cone. He designed a sphere to serve as the sun, and a sphere as the moon. The planets are also spheres. The earth is a sphere. And in geometry, we're going to study why it is that the sphere would be used as this figure for the heavenly bodies that God created. So we're studying magnitudes at rest in the art of geometry. It's important to note that Plato explained in the Republic. The Republic is a long book where Socrates discusses how a state should be designed. It starts out with a question about justice and then gets into a discussion of how a country should be organized or a city should be organized. And one of the focal points of the Republic is a discussion about how the people in the state should be educated, what should be known by the leaders of the state, what should be known by the soldiers of the state, what should not be allowed to be studied by anyone because it corrupts people. And one of the first studies that Plato calls for in the state is the study of geometry. And he gives two simple reasons why geometry is so important when it's studied rightly as classical geometry. First, he says that the study of geometry raises our thoughts to the eternal. The study of geometry helps us to lift our thoughts out of this world of change and death to a world of eternal sameness where things don't change, things don't die, there's no corruption, everything is the same. That meditation, which we understand simply as a meditation on God himself, brings us wisdom and peace because our minds are fixed on things that are eternal and do not change. And that's the source where human wisdom and peace and happiness come from, having souls that are settled and fixed on eternal things rather than the constantly changing, frustrating, and confusing things of this world, this short earthly life. So one of the benefits that Plato talked about in geometry is that it leads us to think on eternal things. The second benefit, which is related to that, is that he said it creates in us, geometry creates in us a spirit of philosophy. It gives us a certain spirit that is the spirit needed for a life of wisdom and philosophy. So our study of geometry is to be pursued, not because this can go on your transcript and because a modern college will think it's impressive. If a modern college is wise, they will definitely think it's impressive for you to study classical geometry. For example, Plato wouldn't allow anyone into his academy unless they had already studied geometry. So if there's a great, wise college or university out there, and they, like Plato, say, we want kids who have studied classical geometry, then yeah, maybe having this course on your transcript will be impressive, but it's probably not going to impress a modern college or university that really doesn't care about wisdom. We're studying this for our own personal benefit, for our own spiritual and intellectual life, for our own happiness. We're studying the art of classical geometry. Now, if you don't study it, and if you don't study philosophy, if you don't study theology, you're not going to understand why these studies are beneficial and how they can help you to become happy. You won't understand because you don't study and learn the wisdom that they make available. What should motivate you, though, is that these studies are recommended to you by the wisest and best men of human history. The people, you see on television, all the troublemakers in our society, the politicians, the celebrities, they don't study these things. They don't recommend these things. The people in your life who just want you to be selfish and sinful, they're never going to encourage you to study these things. But if you could gather around yourself all of the wise men from history, saints and doctors of the church, they would all be telling you to study classical geometry. And you need to trust in the wisdom of the ancients. You need to give it a chance. You need to get into the study, start the learning, and see by experience what effect it has on your mind and soul as you get started. Remember, Plato said the study of classical geometry raises the soul to eternal things and creates in us the spirit of philosophy. I want you to experience that, but in order for you to experience that, you're going to have to do the study. And let that be your motivation, that you can become wise and enjoy the wisdom and happiness that experience in this study will bring you, as all the wise men in the world have told you, if you'll do the work. So that's what should motivate you in the study, not just of classical geometry, but of grammar, reasoning, rhetoric, arithmetic, music, astronomy, moral philosophy, natural philosophy, theology, sacred scripture, and all the rest that we make available in the Classical Liberal Arts Academy. Why the study of geometry is so helpful to us is because it's demonstrative. It's demonstrative. And what that means is that the knowledge of geometry is one field of knowledge that is absolutely true, cannot change, and is just perfectly certain. It's not maybe, it's not an opinion, it won't change in 50 years from now. The knowledge of geometry is demonstrative. And what that means is that in order to say anything in geometry, we require proof. We require that every single point that's learned in geometry about magnitudes at rest be proven and be absolutely certain. There's no opinions, no maybes, no sometimes, no most of the time. The knowledge that you gain in classical geometry is absolutely certain knowledge because it's all demonstrative. It's all proven with clear proofs that are all based on absolutely certain truths. okay? And we can talk about these a little bit now as we think about the elements of geometry. The book that we're going to study, and the book that has been studied by Christians and non-Christians for centuries and centuries, is titled The Elements of Geometry by a teacher named Euclid. Euclid lived around 300 BC, which is just a little bit after Aristotle. And Euclid wrote the book. He was the master of the art of geometry. And the title of his book is The Elements of Geometry. And the first thing we should ask is, what are the elements of geometry? Well, remember that geometry is demonstrative. So everything that's said in geometry is proven to be absolutely true because it comes from statements that we know are true. All of those true statements that we reason from are called the elements of geometry because all of our knowledge in geometry is built from those elements, okay? The building blocks, the basic building blocks of all of our knowledge in geometry. That's why the book is called The Elements. Now, as we get started, if you look at the first lesson in classical geometry, you'll see that it's about definitions. Definitions are the first of the elements in geometry. What we're going to do is we're going to establish, I think it's 36, let me just check. 34. We're going to establish 34 definitions of terms that we're going to use in geometry. And these definitions are important because what we're going to do is make sure that any time we use any of these terms, we use it in exactly the same way, the meaning never changes, and it's always absolutely certain what we mean by these words. We established the definitions of terms right in chapter 1 or lesson 1 of our study in geometry. That's the first part. The second part, we're going to study axioms and then postulates. Axioms are statements that we know are absolutely true because they're self-evident. They don't need any proof. An example of an axiom is that a part is less than a whole. That's an axiom. It's self-evident. In order to be a part, it must be less than the whole. Okay? If it was equal to the whole, it would be the whole. In order to be a part, it must be less than the whole. So to say a part is less than a whole is an axiom. It's a self-evident, absolutely certain truth that needs no proving. Okay? We're going to learn axioms because these are going to be the statements that we're allowed to reason from in our study in geometry. And then lastly, postulates. Postulates are simple operations that we're allowed to make that don't require any proving. So for example, if we have 2 points, we're allowed to imagine, when we say draw, realize when we say draw in geometry, we're only using that term in sort of a symbolic way. We're drawing it mentally. When we actually draw a visible line, we'll find that the line that's drawn doesn't actually meet the definition of a line. And we'll talk about that in this lesson. But we can take a postulate that tells us if there are 2 points, you may draw a straight line connecting those 2 points. It's a simple operation that we're allowed to make because it doesn't require any steps or proofs to give us permission that we can make that without creating something that might be false or not absolutely certain. There's steps we can take in construction that are safe and certain, and we learn them when we study the postulates. So definitions, axioms, and postulates are the elements of geometry, and we're going to study them in the first 3 lessons of this course. Lastly, propositions. Propositions are problems or theorems that need to be solved. We need to solve them with the elements, and that's what we're going to do in geometry. In book 1 of Euclid's geometry, there are 48 propositions that we're going to solve, and all of them will be solved using the elements of geometry. All of the solutions will be absolutely certain because they're all made with the elements which we know are trustworthy and need no proof. When we solve a proposition, when we come to a solution for a proposition, that solution, because it has been demonstrated, can then be used in the solution of future propositions. So some propositions will be solved from definitions, axioms, and postulates directly, but other propositions will be solved by these and propositions that have already been solved and have been demonstrated. Okay? So what the elements become as we go through geometry are the definitions, axioms, postulates, and prior propositions that are solved in our study of geometry. And what we'll do is build a knowledge of geometry that's absolutely certain. And that quality of knowledge, that quality of absolutely certain knowledge, is what Plato means when he talks about the spirit of philosophy. Learning to have that kind of a standard where you only admit things philosophically that are absolutely certain is the spirit of philosophy. You don't listen to opinions. You don't listen to the news gossip. You don't listen to something that may be true or may not be true or may change. When you learn to appreciate things that are absolutely certain and only allow yourself to be moved by things that are absolutely certain, you can begin to develop the spirit of a philosopher, of a true wise man. That's how geometry helps to cultivate that true spirit that Plato said no one was allowed in his academy until they had first developed that taste of absolute truth. Okay? Geometry helps us to establish that. That's not why we study geometry. We study geometry because we want to learn the art of magnitudes at rest. But one of the broader, greater benefits of this study is that it develops in us this sense of absolute truth in our reasoning and thinking that will help us in all other studies and in life in general. Okay? So that's an introduction to the study of classical geometry. As you go through this lesson, as I said, this first lesson consists of 34 definitions. And these definitions must be memorized exactly. Now, I tend to say to students that it's okay to move on to the next lesson before you've memorized all of these definitions, because memorizing 34 definitions does take some time, and it can get boring if you're just stuck on this one lesson for a long time. But the reason why memorization is important is because you have to remember that every time you use one of these words in geometry, you must use it exactly as it's defined in lesson 1. That's the whole point of a definition. Anytime you use one of these terms, you must use it with this exact definition. And you must also remember that anytime Euclid uses one of these terms, he uses it with this exact definition. Okay? That's why it's important to memorize these definitions. But at the very least, when you read or use these terms, you need to go back to the definitions and make sure you use them exactly as they're written and learned, and that you read and understand the terms exactly as they're written. And I'll give you an example of why this is important. If I look at definition 15 in lesson 1, we learn the definition of a circle. Okay, and here's our definition. It's a little bit long, but just bear with me here. A circle is a plane figure comprehended by one line, which is called the circumference, to which all right lines falling from a certain point within the figure are equal to each other, and this point is called the center of the circle. I don't expect you to have that memorized, of course, but what I want to show you is I can do things now in geometry based on that definition alone. For example, let's say I have a circle in one of my propositions, and there are two lines. One line goes from the center of the circle to the circumference, or the actual line of the circle itself. There's a straight line going from the center to the outside of the circle, and there's another line going from the center to a different point on the outside of the circle. I can go ahead and conclude that those two lines are equal to one another because of the definition of a circle. Okay, listen again. Those two lines, I can conclude that they are equal, and my proof is the definition of a circle. Listen, a circle is a plane figure comprehended by one line, that's the circle itself, comprehended by one line, which is called the circumference, to which all lines falling from a certain point within the figure are equal to each other, and this point is called the center of the circle. So the fact that any line drawn from the point of the center of the circle to the circumference is equal to any other line is established in the definition of a circle. That's what a circle is. So if you say this figure is a circle, I can conclude that any line drawn from the center point to the circumference is equal to any other line drawn from the center to any other point on the circumference. I can conclude that because the definition of a circle says that all of those lines from the center point to the circumference are by definition equal. Okay? So the definition and the details of the definition actually become the proofs for conclusions that I'm able to draw as I work with these different figures. Now, I know this may be a lot of information and you haven't had a chance yet to study these definitions, and all that you need to know in lesson 1, not even this introductory information, in lesson 1, all you need to know are the definitions. So it's time now for you to get to work as the student, and my recommendation is for you to memorize all 34 definitions in lesson 1 of classical geometry. Memorize the definitions. You can do it. It just takes work, and you have to invest this work and sacrifice to get this work done, trusting, as I said, that the wise men and saints and doctors from history in the church, not just wise men outside, wise men in the church, recommend to you the study of geometry because it's beneficial for you spiritually. Okay? Study trusting in the wisdom of the ancients, and you'll see that spirit of philosophy begin to be developed in you, and you'll begin to enjoy the benefits that are available through the study of classical geometry. So lesson 1, memorization of the 34 definitions for book 1 of Euclid's Elements. There are some notes that I've added in the lesson just to point out some important points, but most of this is simple memory work that you can do. It just takes some effort, and the only way to do it is to do it. So I hope this introduction is helpful. Watch it again if it was a little bit too much. As I mentioned at the beginning of the video, it may be helpful to go back and watch the Introduction to Classical Arithmetic and then get to work on your lesson. Follow the instructions, complete the assessments, and let's go, because this is a fun study. Once you get past these first few lessons into the propositions, the study of geometry is a lot of fun. So get through that first challenge of memorizing definitions, and I'll be ready for you when you get to lesson 2. God bless your studies.